Simplify each expression and write the result with positive exponents. By the way, for those of you who are going to be going on to, say, college algebra, not as much in college algebra, or even in calculus, especially calculus, it's not unusual for us to leave things in negative exponents. It really isn't. The only reason why they have you to write things in only positive exponents are two reasons. One is because of the fact that it gives you practice using the properties of exponents. And two, which is probably more important, there's only one answer they have to put in the back of the book. That's the same thing that they do when they say, write your answer in slope-intercept form. There's only one way to write it in slope-intercept form. So they only have to put one answer in the back of the book. So makes life easier for them. That's the same thing what happens on the computer models. They'll ask you to put it in a certain format. Well, why? Because there's only one way. There's not going to have to be, if they check your answer is only that thing. Instead of saying, okay, you can write it 5 different ways, and then they try to pick out all the ways and then compare it to what you've put in. That's why the computer programs become so hard. Okay, here we go. This is what ends up being interesting. Okay, using properties of exponents. These are going to be the big three. A to the m times a to the n. If the bases are the same, you add the exponents. Bases are the same, subtract the exponents. And then here, a to the m to the n power is a to the m times n. And we're going to be using these all the way through. Now, what I want you to notice, and this is kind of a little fine point here, is that if I look at 3/5 and 1/2, the denominators are different. They're different radicals. This guy's a fifth root. This guy is a square root. So if I look at it using the properties of exponents, this is if the bases are the same, you add the exponents. And now we have the old common denominator thing. We're fractions. So it's going to be x to some power. The common denominator is 10, so I'll be multiplying this guy by 2 over 2 and this one by 5 over 5. So this is now 6 over 10 plus 5 over 10, which is x to the 11 over 10. Now I've got something that is under a single radical. I've got something that's under a single radical. 5 to the 1/5 divided by 5 to the 6/5. Well, this is to, if the bases are the same, you subtract the exponents, so it's 1/5 subtract 6/5. The denominators are the same. That means they're the same radical. So 1/5 minus 6/5 is 5 to the negative 5/5, which is 5 to the negative 1, or they say write it with only positive exponents. This becomes what? 1/5. X to the 3/7, and it's a sevenths, and it's times, bases are the same, so you add the exponents, negative 6/7. So if you multiply, bases are the same, you add the two exponents.
Oh, because I'm looking at the one.
Yeah. This is x to the negative 3/7. And they say write it with only positive exponents. This turns into 1 over x to the 3/7. Now here's the one that was above. If I have a to the m times a to the n, it's a to the m times n. So this is really a to the 4 times 5/4. Which is a to the 20/4. And 20/4 is a to the 5th. Now here's that 3/2, which means, remember, what do we do? Well, one thing we could do, we could square root it, then cube it, but that's not exactly what they planned for us to do with this, which is what I would do, by the way. I'd square root it, then cube it. But there is an exponent of 1 on the 9. That should look familiar with the stuff we did with whole number exponents. So this is 9 to the 3/2 times 1, which is 3/2. X to the 6 times 3/2. 9 to the 3/2 is the square root of 9 cubed. X to the 18 halves. And yes, you could reduce the fraction down here instead of doing what I did. This is square root of 9 is 3 cubed. 18 halves is x to the 9th, which is going to turn into 27 x to the 9th.
So you just separated it, you just took 9 to the 3/2 and
Yeah.
you took x.
Because they wanted me to use the properties of exponents.
Okay.
If that weren't the case, I would have done the square root of 9x to the 6th and then cubed it like we would have previously.
Mm-hmm.
But they said use the properties of exponents, so we're kind of stuck there.
Okay.
Now, this is a 1. So this becomes 2 to the 1 times 3, x to the 2/3 times 3, y to the negative 1/2 times 3. Using the property of exponents. This is 2 to the 3, x. Well, if this is over 1, the 3's reduce out, you're left with an x squared. Or you could say 6/3, but 6/3 is 2. And I can't do anything with this guy. He is negative 3/2. There is nothing wrong with that answer. Now, what your book would say for you to do is, it says write it with only positive exponents. Exponent on 3 is positive. Exponent here is positive. This guy's negative. The only one that moves down is this one. Because this becomes 8x squared, positive exponents. Property of exponents says this is y to the 3/2. And that's a perfectly good answer, but that's not the one your book would have. Why? Because this is over 1, this is over 1. So they multiply across 8x squared over y to the 3/2. Perfectly, good answer. And like I said, that's what your book would do.
So pretty much just take the negative and put it under all of it.
Yeah. Because as you can see, is these are all multiplications. So the negative moves down, and then when you multiply, it multiplies all the way across. and you've got a 1, 1, and that guy that moved down, and then you have the guys on the top and the 1. So essentially, it just moves down. It becomes the denominator. Now this guy can be unpleasant. This is 2 to the 3, x to the 2/3 times 3, y to the negative 1/2 times 3, over x to the 2 times 3, using the properties of exponents. This becomes 8. 3 times 2/3 is just x squared. Unfortunately, this then becomes y to the negative 3/2. And then 2 times 3 is 6. And then we can reduce stuff down. This is 8. The y to the negative 3/2 moves to the denominator as a y to the 3/2. There are 2 x's in the numerator, 6 in the denominator, which is going to leave me with an x to the 4th in the denominator. And poor little 8 is left all alone in the numerator. All by himself. He's been deserted by everybody else. This, because of the subtraction, this is a distributive property. The good old distributive property. So, and because these guys are fractions, you end up with tons more steps than you would normally, because normally if they were whole numbers, we would just do it here as we would remove the parentheses. Because there's fractions, we're going to end up having to deal with the fractions as we go across. So this would be x to the 1/4 times x to the 1/4 minus 3 x to the 1/4 times x to the 3/4. See, now we have to deal with the concept. Yes? Yeah. Yes, there's your x to the 3/4.
You have it flipped. Sorry.
There's the negative 3. There's the x to the 1/4 I'm multiplying in. There's the x to the 3/4 that was there.
Negative 3x to 3/4 instead of 1 to the 4th.
The 1/4 is what I'm multiplying through.
Yeah, but
There's your 3/4 right there. So here's x to the 1/4 times x to the 1/4 minus 3. There's your x to the 1/4 times x to the 3/4.
Oh,
there's 3 different things. Okay. I forgot. Gotcha.
So this would be x to the 1/4 plus 1/4 minus 3x to the 1/4 plus 3/4. X to the 1/4 plus 1/4 is 2/4 minus 3. X to the 1/4 plus 3/4 is 4/4 x. X to the 2/4 is 1/2 minus 3. X to the 4/4 is x to the 1. These are not fun problems. What they're doing is trying to get you to be more comfortable with working with things with exponents. Fractional.